Hello class, this is a video tutorial on further trigonometric identities by relating values to one another, as well as introducing other geometric proofs. Properties arise which can be utilized in the future. So let's first take a look at the complementary angles. So for any angle, theta, if we take the complements of these, so sine theta is equal to the complementary of that angle. Cosine theta is equal to the complementary of sine of that angle. And same thing with tangent, the complementary of cotangent is there, which by the way is where the name arises. Sine and cosine, which is cos. It's the complementary of sine. If we do this in terms of actual numbers, let's take a look at these two values. 43 plus 47 are complementary angles because they add to 90. Now if we take the sine of one of the values, so let's say sine 43 and cosine of 47, it will equal to the same value. Same thing if we do cos 18 and sine 72. There we go, and so on. Now, it's one thing to memorize this, but let's actually prove that this is true for any angle. So I have here a right angle triangle with theta as my angle, and we already know SOHCAHTOA, so I've put the ratios for these. Now let's find what this angle is here. Well, let's consider that the angle sum of the triangle has to be, 180. So 90 plus this angle, 90 plus theta plus, let's label this angle, let's label it x, should equal to 180. If I solve for x, we get x is equal to subtracting theta and subtracting 90. So 180 take away 90 is 90 minus theta. So that angle is theta. So this angle is 90 minus theta. So now if we find the cosine of 90 minus theta and the sine of that angle and the cotangent, the cot of that angle, let's take a look at what happens. Cosine of this angle, it's adjacent over hypotenuse, so it's going to be adjacent over C, the hypotenuse. So this is going to be B over C. And would you take a look? It's the same thing. Same thing if we did sine of the angle. Sine of this angle here, 90 minus theta, is A over C, opposite over adjacent, A over C. I realize that should be C. And if you take a look, they are the same value. And lastly, if we do cotangent of this angle, so normally if we do tan of this angle, it's opposite over adjacent. But in this case, it's going to be adjacent over opposite. So it's going to be B over A. And if you take a look, it's the same value. And we could apply this also to secant or sec and cosecant. The next proof that we should know is the tangent identity. It's as follows: tan of theta is equal to sine over cos, and cot theta is cos over sine. This proof we've actually already seen, but let's do it again here. We already know from the unit circle that sine relates to the opposite of our reference angle, and cosine relates to the adjacent of our reference angle. Tan is opposite over adjacent, in which case it's going to be y over x. But if you take a look, y is equal to sine, and x is equal to cosine. And as we know from the reciprocal of tangent, cot of theta is just the reciprocal of this ratio as well. One last identity, it's called the Pythagorean Identity. It's this very special one here. Please be very familiar with this one because it'll be used a lot. Sine squared theta plus cos squared theta equals 1. And we can also find other resulting identities from this. If we take cosine and move it to the other side of the equation, it becomes minus cos squared. So we get sine squared theta is equal to 1 minus cosine squared theta. And if we do the same for sine squared, if we move this to the other side, it will become negative sine squared theta, leaving us with cosine equaling 1 minus sine squared theta. And here's the proof of how this might happen. So from the unit circle once again, and the Pythagoras theorem, we can say that y squared plus x squared equals 1 squared. Well, 1 squared is just 1. But we know that y from the previous is equal to sine. So we'll substitute that. Y squared is sine squared theta. X is, well, cosine. That is cos squared theta. And 1 squared is just 1. And here is the proof for this identity. Extending this identity a little bit further, if we take the identity sine squared theta plus cos squared theta equals 1, and we divide every term by cos squared theta, let's take a look what happens. We get sine squared over cos squared theta. Well, as we've seen from the tangent identity, sine over cos is just tan. So sine squared over cos squared is tan squared. Cos squared over cos squared, that's 1. And 1 over cos squared, well, 1 over cos is sec. So 1 over cos squared is sec squared. If we do the exact same thing, but this time dividing by sine, sine over sine is 1. Cos squared over sine squared is cot squared. And 1 over sine squared is cosec squared theta. There's a little mnemonic that I was taught to remember this, but I'll demonstrate it to you now. A man with a tan is sexy. A man with a cot, he's cozy. So, it's a little mnemonic for you to remember, but mainly we should be remembering this Pythagorean identity, the tangent identity, as well as the complementary identities. In my next video, I'll be demonstrating to you how these might be used, and I hope to see you then. Best of luck.